The cosine rule. So you can find this formula on page 16 of your formula and tables. And the formula is a squared equals b squared plus c squared minus 2bc cos a. So we use the cosine rule with non-right angled triangles to find a missing side or a missing length. What we do is we label our triangle capital A, capital B, capital C for the angles. And whatever angle that we actually have must be labelled as angle A, because we have cos A in our formula. So whatever angle we actually have must be labelled as angle A with a capital A, and the other two, it doesn't matter which is B and which is C. Then the side that's opposite angle A gets labelled as lowercase a. The side that's opposite angle B gets labelled as lowercase b, and the side that's opposite angle C gets labelled as lowercase c. Note, if the two lengths of two sides of a triangle and the angle between these sides are known, then we can use the cosine rule to find the length of the third side of the triangle. Note, if we know the lengths of all three sides of a triangle, then we can use the cosine rule to find the measure of any angle in the triangle. Just making sure that the angle that we're looking for is labelled as angle A. So if we know two sides and the angle in between them, and we're looking to find the length of the third side, we can use the cosine rule. And if we know all three sides and we're looking to find any angle, we can also use the cosine rule so long as we label the angle we're looking for as angle A. Whereas if we know an angle and the opposite side, that's when we use the sine rule. But if you're ever unsure, you could always try the sine rule, and if it doesn't work out, then go to the cosine rule. So here we have a triangle, FEG, and we want to find x, the distance from E to G. So we want to find this distance here, x. So the distance from E to F is 8, the distance from F to G is 10, and the angle EFG is 50 degrees. So we're trying to find x. So we have one angle and we have three sides, and we're trying to find one of the sides, which is EG, and we've labelled it as x. And we want to give our answer to 2 decimal places. So we're going to use the cosine rule. So we have a squared equals b squared plus c squared minus 2bc cos of a. And what we have to do is label the angle that we have as angle A. So this now becomes capital A. And then the side that is opposite it gets labelled as lowercase a. Okay, so then it doesn't matter which way I label the other two angles. They can be B and C or C and B. But I'm going to label G as capital B. And therefore the side opposite that is going to be lowercase b. And I'm going to label the last remaining angle as angle C. And the side that is opposite that is going to be lowercase c. Okay, so now all I have to do is substitute into my formula. So I swap a for x, so I've got x squared on the left of my equal sign, equals, I swap b for 8, so b squared, plus I swap c for 10, so I've got 10 squared, minus 2 times b, which is 8, so 2 times 8, times c, which is 10, so make sure you've got brackets around all of these, and then I've got cos of a, which is 50 degrees. Make sure that you close the bracket on your calculator when you put in the 50 degrees. So put all of this into the calculator, 8 squared plus 10 squared minus 2 times 8 times 10 cos of 50 degrees. And it's going to give you 61.15398. So this is what x squared is equal to. So we have to get the square root of this to get what x is. So the square root of 61.15398 is going to be 7.82 to 2 decimal places. Find the measure of angle theta. Give your answer to the nearest degree. So here we have a triangle PQR. Angle Q is labelled as theta. The side PQ is labelled as 7. The side QR is labelled as 10. And the side PR is labelled as 12. So when we have three sides of a non-right angle triangle and we're trying to find any of the angles, we can use the cosine rule. So the cosine rule again is a squared equals b squared plus c squared minus 2bc cos of theta, or cos of a. And what we're going to do is start off by labeling our triangle A, B and C. So we always have to label the actual angle that we have, or the angle that we're looking for is angle A. So I'm going to change this capital Q to a capital A. So then the side opposite that is going to be lowercase a. Then it doesn't matter which way I label the P and the R, so one of them has to be capital B, one of them has to be capital C. So I'm going to label the capital R as capital B, which means that the side opposite that is going to be lowercase b. So then the last remaining angle, which was P, is now going to be capital C, and the side opposite that is going to be lowercase c. So then I just have to substitute into my formula. So my formula is a squared equals b squared plus c squared minus 2bc cos of theta. Now that's really cos of a in our formula book, so I'm just going to change that to an a. So we're going to swap the a for 12, so we've got 12 squared is equal to, we're going to swap the b for 7, so 7 squared, plus we're going to swap the c for 10, so 10 squared, minus 2 multiplied by b, which is 7, multiplied by c, which is 10, times cos of theta. So cos of a now becomes cos of theta. Or it could be cos of x, it doesn't have to be cos of theta. Then we're going to work out as much as we can. So 12 squared is 144, 7 squared is 49, 10 squared is 100, minus 2 by 7 by 10 is minus 140, and we still have cos of theta. So bring down 144. Then 49 plus 100 is 149, and we still have minus 140 cos of theta. So then we're going to bring the 144 over the equal sign, and we're going to bring the minus 140 cos of theta over the equal sign as well, because we want our cos on the left of the equal sign, but it doesn't really matter too much if it's on the right. So minus 140 cos of theta comes over the equal sign and becomes plus 140 cos of theta. That's equal to 149 hasn't moved, it's still where it is, so that stays the same. And 144 came over the equal sign and became minus 144. So 149 minus 144 is 5. So to get the cos of theta on its own, we need to divide by what's stuck on in front, which is 140. So we're going to have 5 divided by 140, which is 5 over 140, which is 1 over 28. Now, we need to find what the angle is, and the rule is when we don't know the angle, we use the inverse function. So the inverse of cos is going to be cos to the power of minus 1. This is the inverse function of cos. And in order to get this up in the calculator, we press the shift button and then we press cos. In some calculators, it's a second function. So when we don't know the angle, we use the inverse. So we get that by pressing shift. So we'll press shift, then cos, and cos minus 1 will come up. A bracket will automatically open. We're going to press the fraction button, put in 1 over 28 and close the bracket. If we don't close the bracket, we'll get an error on the calculator. So the inverse function of cos times 1 over 28 will give us 88 degrees rounded off to the nearest degree. So angle theta is approximately 88 degrees.